Hello everyone, and welcome to another episode of Advent of Code 2016. As you can see here, we're a bit behind. I've mentioned in previous episodes that I just have not really had time to do much of this, but it's the weekend. Maybe I'll be able to catch up. Who knows? I have a sort of busy weekend too. Let's take a look at day 9. Explosives in cyberspace. Wandering around a secure area, you come across a data link port to a new part of the network. After briefly scanning it for interesting files, you find one file in particular that catches your attention. It's compressed with an experimental format, but fortunately the documentation for the format is nearby. The format compresses a sequence of characters. Whitespace is ignored. To indicate that oh no, I've seen this, I think. Something sort of like this. Anyway, to indicate that some sequence should be repeated, a marker is added to the file like 10x2. Oh, I see. Is it it's in parens or something? To decompress this marker, take the subsequent 10 characters and repeat them 2 times. Then continue reading the file after the repeated data. The marker is not included. Interesting. If parentheses or other characters appear within the data referenced by a marker, that's okay. Treat it like normal data, not a marker. And then resume looking for markers after the decompressed section. Okay. All right. This is not... This just gave me, like, flashbacks to a really hard interview question that I had not too long ago. But it turns out, unsurprisingly perhaps, that the thing that made the interview question hard is not present in this simple exercise. But the format just looked very similar, and I was like, no, please, don't make me do it live on camera. I couldn't do it live in the interview. I don't know. It was a hard problem, and I think it was intended to be one that almost nobody ever solves all of. And I just had to be okay with like solving some of it. Okay, so what exactly is the data structure that we want to represent? Well, actually, let's look at our input here first. Okay, so is it all one big line or what? I'm not sure, but I suppose Emacs will tell us, right? Yeah, it's all one big line. 14 kilobytes of text all on one big line. So what we need is 141, 8. Okay, so like in our example input, the first thing is a marker, and after it are exactly 8 characters. So we're supposed to repeat these 8 characters 10 times. And then there's this like 141 that we're supposed to repeat 10 times. And then another thing that looks kind of like a marker but isn't, that is supposed to be included in the output that is repeated 10 times. And after that, it becomes like really hard for a human being to figure out what's supposed to be going on. So one question is, like, we could figure out a data structure for representing this, but it's kind of hard to parse this in a non-contextual way, right? Like, it would be kind of nice, perhaps in an ideal world, to parse this string and turn it into a list of instructions. And like the first instruction is, here's a marker of, not even an instruction, but parsed bits saying, okay, this is a marker. And it's 8 by 10. And then like the next thing is, this is a character. This is a character. But it gets a little bit hard to have this thing parse as a marker, and this thing just parses some characters if we're just running an independent parse step. followed by an interpretation step. It seems like, however, it would not be very hard to process the string as we look through it all at once. Basically, at every step in our loop, we're going to look at the beginning of the string and see if it's a marker. See if the regex for marker matches here. And if so, then we'll... we wouldn't have to use a regex. But I think it's pretty simple to do so. Anyway, we could check to see if the marker for if the regex for a marker matches, and then if so, read the requisite number of characters and repeat them that many times. And otherwise, just output the character and move on. So I think that that's an approach that seems reasonable. Not having an intermediate parsing step seems like it will make things easier. Put another way, having an intermediate parsing step would make things more complicated. What is the decompressed length of the file? Don't count white space. Oh, what was... They said some other stuff about white space, didn't they? White space is ignored. Okay. They're just pointing out, like, there's one new line at the end, right? And that's the only bit of white space there is. Yeah, there's no spaces anywhere else. So, fine. We don't have to worry about white space as long as we trim the line. Have you guys been looking at the screen the whole time? I don't remember. Here you go. This is what our puzzle input looks like. I was talking about this stuff. Who knows? You just gotta roll with it. Yeah, still don't have the hang of putting the right window on screen. Tough luck. So we probably can just import RE. We shouldn't need the regex package that we got in the previous episode. Now, it's sort of tempting, I think, to actually produce the output string and then count it, but I think it could be quite large, and we may not need it. Hey, I said to go look at the code. I don't know. I think I pushed the wrong button or something. Anyway, here we are. Import RE. The output string is going to be, I think, quite large because, like, I mean, right? This is adding already 1 kilobyte, and there's stuff like that all over the file, and probably some that are larger. Maybe it's going to only be a couple megabytes, but it's still like not going to be super efficient to have. The thing is, like, we want to be ready for part 2 as well, and part 2 may need to know some, like, it will surely want to know some detail about the output string. So maybe what we can do is define a you might call it an interface if we were working in, say, Java, but it'll really just be a function that takes arguments of a certain type for, like, basically accepting. Well, actually, I guess we probably can just use iterators and yield, and then everything will all be lazy and it'll be fine, right? Yeah, that should be fine. Okay, so we'll yield a lazy sequence of all the characters in the file. And that'll be a little bit unnecessarily expensive, but not too bad, I think. Yeah, all right. So let's try just writing a single generator function that takes in a string and produces a stream of characters from the string. It'll probably want a couple of helpers, but we'll start with the top level of this stuff. So def decompress of s, and we're going to say I equals 0. And we're going to do a while loop for I, rather than doing a for loop, because we want to be able to make I jump around when we process marker stuff. So what's the idea here? While I is less than len of s, yeah, that sounds right. I was typing real hard there. I don't know. Maybe it sounded loud to me. I bet it was loud to you guys. I don't know why. Just my fingers seemed very enthusiastic. So what we're going to do is say if marker dot match. No, hang on. I have to remember Python regex matcher object. How do you make one of those? You had to you compile the regex and then you make it be a matcher for a string somehow or other. Match objects. No, not that. Regular expression objects. Okay, so we compile a regex and then we pass it a string and a position. Okay. So let's just compile one now. Marker regex equals a regex of what? An open paren, some number of digits, an x, was it? Yeah, an x. And then some more digits. And then close the, yeah. Why does it say this is a mismatched parenthesis? Oh, I see. Because it knows that this is part of the, okay. So that's the marker regex. M equals, oops, I guess we have to write re.compile of this equals marker regex dot match of s at I, right? Yes. Okay, fine. If m, then we want to yield all of the stuff. What? Okay. What's in a match object? We can call groups or group, I think. I see. Okay. Yeah, m.group takes an argument. Fine. Start and end span? Do I need spans at all? I think not. I just need start and end, right? Yeah. Okay. So let's see. We need to extract the part of the string that matched. Let's pass. Let's not do anything there yet. And then we'll say, all right, what if it didn't match? Well, we're just going to yield S of I, and then I equals I plus 1. Okay. That seems pretty, like, not that exciting, but fine. And we'll just print len of... God, how do you get the... Is it count or something? How do you get the actual length of a generator expression? I know it's throwing it all away. That's the point. Python compute generator length. How to len of generator. They have no length. I know. Len of list of whatever. Yeah, of course, but that's awful because you have to realize it all. All these people are asking, like, people are answering this question like, oh, you should never want to know the length of a generator. And, yeah, like, that's true. If you wanted to actually use the contents of the generator, you can't ask the length. But if all I want to know is the length, that's a perfectly reasonable thing to want to know. And I guess I'm just supposed to write print sum of 1 for nothing in decompress line.rstrip. Right. So, sure? Does this run? Oh, no, of course. Instead of pass, let's say I equals I plus 1, just for our testing to see if we can handle. Okay, so we've discovered that there are 13,095 characters in the string in the input, not including ones that look like marker. Not including, in fact, left parens, I suppose, right? That's interesting. I guess that means there must be about 1,200 left parens in the file? That doesn't seem right to me. Maybe it is, though. Wait, that can't be right. I must be getting something wrong. Not 1,200. That's... Yeah, no, 1,200. I wonder what... Are there really 1,200 of them? It doesn't seem like it, but maybe I'm just crazy. I guess there are a lot, huh? How would I find that out? grep isn't exactly right. Can I search for like number of matches? I don't know. Forget it. It doesn't matter. I think the answer that we got is actually right, but it's not an answer that matters, so we'll leave it alone. Now all we have to do is handle this m thing. And what we're going to do is say, what happens if you slice a string? A, B, C, D, E, F of 0 to 3. You do get a string. Not a surprise. What we'll write then is that to repeat equals S of... Well, let's see. End, I suppose, equals m dot group of... What order are these things supposed to be? The first one is how long a string to repeat. So that's group 1 plus m dot end. Let's see, what is end? And, oh wait, that's the one that takes a group. How do I get the end of the whole match? Is that supposed to be 0, or? M.start of 0, M.end of 0, yes, okay. M.end of 0 in this input, sorry, let me show you guys, I'm looking at this paragraph. Note that M.start of group is, yeah, okay, fine. M.start of 0 is 1. Because we're matching the regular expression starting with B, and it's here. M.end of 0 is 2. Which is the space in between the B and the A, basically. Alternatively, you can say that it's the A, but we don't include it. Okay. So end is the first character not to include, that's not included in the match. Fine. Yeah, so we just want to write m.end here of 0. Right? In fact, we can write start equals m.end of 0 and use start here, because we're going to need it again in a moment. And then say s equals you know, we could probably do even better instead of iterating over. Whatever, we'll just do it the slow and silly way. S equals, not S, to repeat equals S of start to end, right? I think so. M.end of 0 is where the match ended, and therefore where the thing to repeat should begin. And then we just add the int of group 1, which is how many characters to include in the thing. That seems fine to me. Okay. And then we'll just say for nothing in range of int of m dot group of 1, no, group 2, actually, yeah, nothing, for C into repeat, yield C. So it's a bit like barbaric to yield single characters and do so probably thousands to millions of times. We could do better by yielding strings. And in fact, let's just yield to repeat some number of times. And then at the end of this, set I equal to end? Yes, because we've processed up to but not including end already. And so we want to start the next iteration of the loop at end. And we'll just write this. So now we actually do care about the contents of the generator. Fine. For each string being yielded, we will add up the lengths, and that'll be the final result. And we'll print that, and we don't need to print done. How's it look? 183,269. All right, well, it wasn't megabytes after all. But it was 100 kilobytes. So we weren't too far off. What do you think, Advent of Code? That is the right answer. Incredible. And it didn't actually take that long. 25 minutes. Part 2. Maybe we can get it in. Apparently, this file actually uses version 2 of the format. Very funny. In version 2, the only difference is that markers within decompressed data are decompressed. Ugh. Yeah. So 3x3 of this produces, x produces an x, and then 8x2 says look at the next 8 characters, 3, 4, 8 up to here, and then output them. Okay. Fine. So we don't need enough memory to decompress the whole thing directly into memory and actually keep the whole string. That's why we're using generators. We're not limited by memory, but we might be limited by compute time. Like, how fast can a computer churn through several gigabytes? I don't know. Probably not very quickly if you're doing it yielding one character at a time. Although I guess in practice we're not, right? We're in all of the complicated cases, we're yielding big chunks of characters all at once. Well, let's commit part 1. Day 9, part 1. And maybe we can try like the most naive possible approach and see if it works. Which basically is just to say, instead of actually yielding the string here on this line, what we can do is recursively call decompress on the string, and for each thing that it yields, we will yield it again ourselves. Right? So for result in decompress of to repeat, we can yield result. So like this could work. Oh no, hang on. Yeah, that's fine. We've sliced the string in to repeat, so we don't have to worry about the decompress call like running off the end of our array or something. So this actually, I think, would be fine. Right? What happens if we just try running it? All right, maybe not, huh? Oh, hang on. I don't remember if I was showing you guys the code at all, or if I was still looking at the browser. But here we are now. I basically just changed this bit here to say decompress the string and then yield the results. However, it's going to take a long time, and I think now that we know, we definitely don't care at all about the characters being output. We can just do a little bit of arithmetic on how many characters it would have been, right? So rather than decompress returning yielding a sequence of characters, we could have it return a number, or perhaps yield a sequence of numbers. I'm not really sure which is whether it is useful to yield a sequence of numbers here, because it seems like in a way that's really all we're doing right now is we're using the string's length as a number basically and yielding a very long sequence of such numbers. And adding them all up is getting hard. So I think that we need to not do it that way, and instead have this thing actually compute a number to return. But fortunately, the number should not be very difficult. So don't yield anything. Don't yield anything. So ret equals 0, which ret is going to be the number of characters that we've that we say this string requires. And at the bottom here, we're going to say return ret. And so this case, of course, was easy to handle. And it's just a slight arithmetic question of what do we do in this case. Obviously, we don't want to do any iterating. We basically just want to write ret equals ret plus decompress this, which is the length of the sequence we're repeating, times this, right? I think that's all. And then we just say I equals end. It occurs to me now that we can no longer implement part 1, right? I had to change the decompression algorithm rather than, I would like to have it compute both parts, but maybe it's fine to not do that. Yeah. Well, all right, whatever. So instead of printing sum len of s, we will just print this decompress call. Okay, compiles, sure. Runs, yeah, no problem. So, I mean, it's only 11 gigs, right? I think we could have eventually gotten there. I don't know if this computer has 11 gigs. It might. Probably it's like 8, right? No, it's 16. So, I mean, I do have enough RAM but we weren't holding it all in memory anyway, right? It's just it would have taken a long time to get there. All right, so how are we doing? Is this number? It is the right answer. Okay, good. Great. So, as I said, it kind of would have been nice if I could make a decompressed thing that still returned the string. But I guess that's the point, is that the algorithm is different enough, and the data that the first thing would return, I don't know, whatever. Shut up. It doesn't matter. So this was, I think, a reasonably compact solution. Pretty straightforward, I think. No big surprises. We had to look up how to use regex groups. Not groups, how to use a matcher object. But otherwise, I think just not too complicated. I'm glad. Some of the last two just like took a long time. Not necessarily because the problem definition was complicated, but there's just a lot of stuff that I didn't know how to do in Python, I guess. Anyway, so that's the end of this episode. Oh no, it's not. Gotcha! It's a trick! We gotta commit. My template. This, by the way, I had a template that I was using. This is where the problem last episode came from. I had typed out the template and then copied it. Anyway, I forgot to commit the template. Oh, go up. Oh, diff. I'm in the I have a bad habit of just saying like yes to every git add-p, which like sort of defeats the purpose of the add-p. But yeah, pretty short part 2. Day 9. Replace part 1 with part 2. Part 2. Okay, great. Now we're done. You're never done until you commit. You don't have to push, but you do have to commit. Good habits. Anyway, thanks for watching, and I will see you next time.